Hey guys, so I wanted to do a couple questions out of the homework for the last part of converting radicals to exponents and vice versa. So we have this property on the screen. Going from left to right, that is going to be your radical form to exponential form. The other direction, this is going to be our exponent form to radical form. So how you're going to see this in the homework is it's going to start with a radical, a root, square root, cubed root, fifth root, and you're going to have to first convert to an exponent. And that is then going to allow you to second use the exponent properties to then simplify from there. So you're going to convert to an exponent. So you're going to convert from a radical to an exponent. And then, because it's now an exponent, I can use those properties that we mentioned in the previous videos. Power rule, product rule, quotient rule, power of a product, quotient of a product, power of a quotient, all of those that are on the formula sheet. Once you've used the exponent's properties, then you may have to do a little simplifying from there, but for the most part, the exponent properties are going to be what build in and simplify it. So have that formula sheet out so that you can follow along these properties with me. Here's our first example. Write in exponent form. The 10th root, so that's what this means, the 10th root of 7 to the third power. So I want to take that radical and convert it to an exponent. So I'm going to use that property at the top of the screen. Base is going to stay the same. So my base is going to be 7. And then the inside number, 3, is what's going to be on top of my fraction. So 7, 3 over the outside number. So that, the 10th root of 7 to the third, written as an exponent, is 7 to the 3 over 10 power. How you're going to type this into Hawks is you will first have to type the 7, and then you'll need to use the exponent button, which looks like that. It's under the math keypad, or you can use on your keyboard the Shift 6, gives you that hat. From there, you'll have to put your cursor into the exponent and then do the fraction button under the math keyboard, or you can use the slash on your keypad, like on your actual keyboard, your physical keyboard. And so that's how you'll type in the 7 to the 3/10 power. All right, number 2, the square root of y to the 4th times the square root of y to the 7th. Now, I don't have the directions written out, but the directions just tell you to first convert it to exponents and then use the properties and leave your answers in exponential form. So don't rewrite it as a radical. First thing I'm going to do is rewrite these with my exponent form. So using that property at the top, I'm going to rewrite this first one as y 4 over, that's a square root, so that's going to be 4 over 2, times y 7th over 2. Okay, so I converted that thing from a radical to an exponent. That's step 1. So convert to an exponent. Now, I may not always be true, but I can simplify that fraction. 4 divided by 2 gives me just plain old 2. So I'll have y squared times y 7 over 2. And then I have a property, product rule that says if you have two of the same bases being multiplied, I can add the exponents. So I've got 2 plus 7 over 2. You can use your calculator to do that, which is going to give me 11 over 2. And that's going to be my final answer. If it would simplify in terms of, if that would simplify, make sure you simplify it, but you do not need to rewrite it with the radical symbol, with the square root, cubed root, that symbol. All right, example 3. First thing I'm going to do, rewrite it in exponents. So I've got y to the 3 over 2. That's that top one. Y 2 over 2. That bottom 2 over 2 is going to give me y to the 1, or just y. So y to the 3 halves over y to the 1. I have a property called quotient rule that says I can subtract these. Running out of room here. Subtract the exponents. So that exponent is a 1, and I do need, when I'm subtracting, to do that. So 3 over 2 minus 1 is going to give me y to the 1/2 power. And again, I don't need to rewrite it as a radical unless it specifically says write in radical notation. But the ones that I pulled out of the homework, all of them say to leave in exponential form, which means leave it with exponents. All right, and then the last one, example 4, looks kind of crazy because I've got a radical on a radical on a radical. First thing I'm going to do is go all the way to the inside. And I'm going to start with that radical all the way inside. So that is going to be x to the 1, and a square root means that the index is a 2. So I'm first just going to translate that to x to the 1/2 power. And that is using the radical to exponent property that was at the very front of the video. I'm then going to drop down the next symbol. So I'm just working from the inside out. Well, now I can simplify this as, keep my base, x, but now I've got 1/2 over 4. So I've got x to the 1/2 over 4. And you can use a calculator to type that in, but 1/2 divided by 4 is going to give me 1/8. I'll just go this way. Okay? And so now I'm going to drop down that final radical and I'm going to do the same thing again. Now I've got 1/8 on top over 5. So my final answer will be x to the 1/8 over 5, which is going to give me, when I simplify that, x to the 1/40. And I can leave that in exponential form. Or if the question said to write it in radical form, I would just use that property the other direction. Oops, too many humps on my M. And that would be the 40th root of x. So either one of those would be correct. And I honestly can't remember what the direction said for that one. But if it said exponential form, you would leave it with exponents. if it had said radical form, you would then convert that back using that property backwards to write it as the 40th root of x. And to type in these odd roots, not odd numbers, but roots that are not square root, you'll use this button in Hawks under the math keypad, and you will just type in the specific number in that little box. So this one you would type in a 40 there, and then you would type in your x inside the radical.